Welcome back, and in this video we're going to discuss about the electrolysis of molten compounds. Now let's take a look at this two diagram first. On the left side, the lead-2 bromide was initially solid. So before lead-2 bromide is heated, it exists as solid, meaning that the ions are held together very strongly by electrostatic attraction between the positive and the negative ions, meaning that the electrons are not able to flow through the wire and hence nothing will happen yet. But if we apply heat here, the lead-2 bromide will become molten and the ions will start to move around as they gain heat energy, and the electrolysis will take place, and we can see it from the light bulb lighting up. Now, during electrolysis, we need to be able to write down reactions at cathode and reactions at anode. So for the equation to take place, the number of atoms must be balanced, and secondly, your charges must be balanced. So let's try to write down equation at the cathode. Since this is lead-2 bromide, we know that we should have Pb2 plus ions and Br minus ions. Lead-2, Bb2 plus, bromide is a halide, so it is Br minus. Since Pb2 plus is a cation, it will be attracted to the cathode, and that is why Pb2 plus will become Pb solid. But you will notice here that the charges are not balanced yet because this has positive 2 and this is 0, and that is why we need to add 2 electrons on the left side. For reaction at anode, Br minus is a negative ion, so meaning that it will be attracted towards the positive electrode, which is anode. So Br minus will become Br2 gas. But the number of atoms are not balanced yet, so we need to balance it first by multiplying this with 2. But you will notice here that the left hand side has a charge of negative 2. 2 into negative 1, so negative 2. And the right hand side has a total charge of 0. So we need to add 2 electrons on the right hand side, and you will have your balance equation. So besides from writing the anode equation and the cathode equation, you need to be able to describe what is happening at cathode and anode. So what you can write here is that the lead-2 ions or Pb2 plus ions are attracted towards the cathode, and the Pb2 plus ions will gain 2 electrons from the cathode, and hence lead solid will be deposited at the cathode. For anode observation, you can write that bromide ions or Br minus ions are attracted towards the anode. Now, I would like to mention one very important information here. You must say that this is bromide ion, and you must say that this is lead-2 ions or Pb2 plus ions. It is not lead ions or it is not bromine ions, because these do not exist at all, and wrongly writing it will deduct your marks. So the bromide ions will lose 2 electrons at the anode. Remember, if you have electrons on the left hand side of the equation, it means that you are gaining, and if you have electrons on the right hand side of the equation, it means that you are losing electrons, and hence bromine gas or Br2 gas is deposited at the cathode, or another way to use this is emitted at the cathode. Now, what happens when you stop heating molten lead-2 bromide, or why does the light bulb stop lighting up when you stop heating? Because when you stop heating, right, if you remove the heat here, the ions will start to cool down, and hence they will form strong electrostatic attraction forces again, meaning that when the ions stop moving, the electrons will no longer be able to flow through the wire. They cannot flow through anymore, so the light bulb will go off. Now, redox reaction is very commonly associated with electrolysis. So let's try to remember this very important phrase here first. While RIC. OIL, oxidation, is losing electrons, and from RIG, we can remember that reduction is gaining electrons. So remember your cathode reaction and your anode reaction. So these are also called ionic half equation because we are only writing half of the equation and not the full ones. So why is this a reduction reaction? In exams, they will often give you the equation and ask you why is this a reduction reaction, or they can also ask you that why is the cathode reaction a reduction reaction? You can simply answer this question by saying that Pb2 plus is reduced from a charge of 2 plus to 0 on Pb. This is the simplest way to answer. Or you can also say that Pb2 plus gains 2 electrons at cathode, meaning that when you gain electrons, gaining electron, this is a reduction reaction. For reaction at anode, why is this an oxidation reaction? Again, you can simply answer this by saying that Br minus is oxidized from a charge of -1 to 0 on Br2. Or you can also say that Br minus ion loses 2 electrons at the anode. Very simple to answer, and if they ask you these questions at exams, you should be able to score full marks. But again, I would like to make sure that you are using the correct terms. Lead-2 ions are reduced to lead, and bromide ions are oxidized to bromine. It's not bromine ions or it's not lead ions. And one thing that I would like to mention in addition is you will only have negative charge or positive charge when your substance is in aqueous or molten state. But when your substance is either solid or liquid or gas, your charge is always neutral, which means that it is 0. So make sure that you are learning this information. From writing down this Walrich and writing down this equation, we can simplify it by always saying that reduction will always happen at the cathode and oxidation will always happen at the anode. This is very easy if you pay attention, but if you are careless, you are going to make a lot of mistakes around this very simple information here. So do make sure you pause the video and absorb all the information now. Now, why is electrolysis of lead-2 bromide a redox reaction? This is also a very commonly asked question. Why is this equation a redox reaction? So you can see here that both reduction and oxidation is taking place at the same time. So that from here, you can score 1 mark. And you can also say that Pb2 plus is reduced from +2 to 0 on Pb, and you can say that Br minus or bromide ion is oxidized from -1 to 0 on Br2. So depending on how many marks is given to you, make sure that you answer according to the mark given. Now, this question is about electrolysis of molten sodium chloride. There's 3 questions asked of you. First of all, write down the half-ionic equations for electrolysis of molten sodium chloride. So I'm going to write the cathode reaction first. So, sodium chloride, what you should do first is break it down. It is NaCl, And since it is molten, we know that it's going to be aqueous. And when it breaks down, it will be Na plus aqueous and Co minus aqueous. Cathode is a negative electrode, so your cation or positive ion will be attracted towards it. So Na plus aqueous will become sodium solid. But your charges are not balanced yet, so we will add one electron on the left side. For the anode reaction, we are left with Co minus, so your negative ions or Co minus ions will be attracted towards the positive electrode, which is the anode. Co minus will be oxidized to CO2 gas. But remember, you need to balance your number of atoms. So we need to multiply this with 2. And since the charges are not balanced yet, I'm going to add 2 electrons on the right side. So this is how you score full marks for writing down the half-ionic equation. Number 2, explain why the cathode reaction is a reduction reaction. So the cathode reaction is a reduction reaction because you can say two things. Na plus is reduced from +1 to 0. Sodium ions are reduced to sodium solid. Or you can say that sodium ions gains electrons from cathode. Explain why the anode reaction is an oxidation reaction. So to answer this question, give me a second. So you can say that Co minus ions or chloride ions are oxidized to CO2 gas with a charge of -1 to 0. Or you can say that since the electrons are on the right hand side, you can say that chloride ions loses electrons at the anode. Alright, now take your time to read this question and write down the half-ionic equations at cathode and anode and explain why this is a redox reaction. Pause the video now to write the answer yourself and then check with my answer. Alright, so I hope that you get the same answer as mine. So, for explaining why this is a redox reaction, it is because both oxidation and reduction is taking place at the same time. Al3 plus ions are reduced to Al solid, and O2 minus ions are oxidized to oxygen gas. Now, these are some of the questions to test out your knowledge on electrolysis. Pause the video right now to select the correct answers, write it down on a piece of paper, and play the video again. There will be answer in a few seconds. Alright, so you are going to do a good job if you can answer all of this correctly, okay? So these are all the basic knowledge that you need to be clear about in electrolysis. But I'll just help you out with one answer here. So when you're answering this type of question, right, what is the product form at the cathode? So cathode is the negative electrode during the electrolysis of molten magnesium fluoride. So magnesium fluoride is MgF2, so it will be broken down into Mg2 plus and F minus. So Mg2 plus is a cation, meaning that it will be attracted towards the negative electrode. So your product form at cathode should definitely be magnesium. Alright, so that is all for today's video, and in the next video we're going to talk about electrolysis of solutions.